Hello guys, welcome back to my channel. So we are continuing the chapter of continuity and differentiability. Till last video you would have seen continuity concepts and exercise 5.1, differentiability and differentiation of basic functions, like how to differentiate a non-implicit function. We'll get into what is implicit function and all. So till that point, I think everything is clear. Like this last question, I've told you to try by yourself. If you have any doubt, you can ask. Now we'll move on to the next part, that is derivatives of implicit functions. What is implicit function? Like, see, till now we have seen functions like directly, right? Um, sorry, directly like sine x square, cos of sine x, sine of ax plus b. So this is very direct, right? Now what if it is in the form of y? Like, for example, y equal to x plus something pi or something like that, like the given this question, right? So how do you find this dy by dx? It's very easy only. Like, there's no specific concept here. We'll just solve through with various problems to understand this. Okay, like for example, this question, if you take find dy by dx, so x minus y equal to pi, right? It's very easy. Like, you can do one method is, see, what is x's differentiation. So see, now in the question they would have given with respect to what you're differentiating. Okay, so is it dy by dx or dx by dy? So this means that you're differentiating y with respect to x. I told this in the previous video itself. Okay, so now you're differentiating this whole equation with respect to x. Now if you differentiate x with respect to x, it is 1, because d by dx of x is nothing but 1, right? Now, if you differentiate y with respect to x, it is just dy by dx. That's all, because you don't have any value of y in terms of x, right? So that's why. And pi is a constant, right? 3.14. So pi's derivative is 0 because it's a constant, right? So dy by dx is equal to 1, right? See? So this is how you solve implicit functions. Okay, we'll see some examples also. Also here, in the textbook they've given derivatives of inverse trigonometric functions. Okay, this is also very easy only. Like, you would have studied inverse trigonometry previously, right? Otherwise I'll try to cover as a separate chapter also. But it's nothing but, like, if you have y equal to sine x, trigonometry from 11th standard, so your x will become sine inverse of y. This is the inverse or trigonometry concept, right? So it is just a reverse. Okay, so we will be able to find derivatives of inverse trigonometric functions as well. That's why they've given this a separate concept. This is actually quite interesting. I'll tell you one example of sine inverse x. Okay, so if you consider here, like, y equal to sine x. Now, sorry, sine inverse of x. You have to find this. Okay, what is dy by dx? Okay, we'll try to solve that in the whiteboard. Okay. Okay, so your y will be sine inverse of x. I'll just solve for sine alone. You can try for other cos and tan and all. Okay, so before that, you have to remember all these formulas from 11th standard. I've just written in case you forgot, because these formulas will come handy for the questions in NCERT as well as any other board exam related questions. Okay, so now this is nothing but x equal to sine y, right? Okay, so we know that sine square x plus cos square x equal to 1, right? So keep in terms of y, we can write, because we are solving for y, right? So we can write sine square y plus cos square y equal to 1, which is nothing but sine square y is equal to, oh sorry, cos square y. I'll tell you what am I doing here. Okay, 1 minus sine square y. Now recall from inverse trigonometry functions that sine of sine inverse x is nothing but x, right? For x belonging to minus 1 to 1. These are concepts from investing. Nothing, okay. If you put x equal to let's say 1, what is what sign is 1? Sin x equal to 1 gives you inside minus 1 to 1. What is x? It is in the first cycle, it is pi by 2, right? Sin 90 is 1. So if you put 1 in this function, you'll get sine inverse of 1. Sine inverse of 1 is nothing but pi by 2 only. Again, sine of pi by 2 is 1 only, no? So you get this x value only in this domain, okay? That's what I'm doing here. Sine of sine inverse x is 1. So you'll get cos square y is equal to 1 minus, instead of sine square y, you can write sine y the whole square, right? So instead of sine y, you can write sine of sine inverse y the whole square. Understood what I'm doing here? Instead of sine y, I'm writing sine of sine inverse y. Why? Because of this property. Okay. Now we have x as sine y, right? So you can put 1 minus x squared. Understood? This is very simple, right? We have y equal to sine inverse of x equal to sine y. So you can directly put 1 minus x square. So this will give you cos y as root of 1 minus x square, right? Very simple only. Like you can just get this from sine square x plus cos square x equal to 1, this formula. Understood? Now what is the actual motto of this? We have to differentiate this, right? So we converted this to this. So x equal to sine y. When you differentiate this, you'll get 1 is equal to sine y. What is the differentiation of sine? Cos. So cos y into dy by dx. You should not forget the chain rule where you have to differentiate the functions inside also. Okay, I've told you in the previous video. So you'll get dy by dx as 1 by cos y. Okay, so you can substitute this here. So dy by dx will be 1 by root of 1 minus x square. Understood? Very easy proof only. This it's not a proof at all. Like it's just playing around the equations. Similarly, you can find for cos inverse x and tan inverse x also. Okay. I think that's all. There's nothing. There's no concept in this exercise itself. We'll directly solve problems. Okay. These first 8 questions are very easy. I'll just solve some 4 of them if you want. Okay. Okay. So we'll take the first question. Like this is nothing but exercise 5.3. Okay. The first question you take 2x plus 3y is equal to sin x. See, your equation is mixed, right? It is mixed with y and x. Just directly solve how you normally solve. Okay. 2x differentiation is nothing but 2 because x's differentiation is 1 plus 3 is a constant. Keep it like that. Y's differentiation is dy by dx. Right? Sin x differentiation is cos x. That's all. Now just bring everything this side. Dy by dx is equal to cos x minus 2 by 3. That's all. That is the answer. Very simple only. Okay. I'll take the second question. I think this is a similar 2x plus 3y equal to sin y. Okay. Nothing. 2x plus 3y equal to sin y. This is just the small differences. The first question they gave x, here they've given y. Same 2x differentiation is 2, 3 dy by dx. Sin y differentiation is cos y into dy by dx. Do not forget dy by dx. Now 2 is equal to cos y minus 3. Bring 3 this side, okay? Bring this whole term this side. So we'll get dy by dx. So dy by dx is equal to 2 by cos y minus 3. That's all. If you want, yeah, you can't do anything basically here. You can make y in terms of x and substitute here, but not necessary. This is the method. I'm just trying to tell the method to solve. Okay, we've done first one, second one, third one also same only. Ax plus by square is equal to cos y, right? Ax differentiation a, by square is b into y square differentiation is 2y into dy by dx. Understood? Cos x differentiation is minus sin x. So minus sine y dy by dx. That's all. So you'll get a is equal to, or you can bring this, okay, anything is fine. You can bring 2by minus sine y into dy by dx. So your dy by dx will be a by 2by minus sine y. That's all. Very simple only. So the problem in this exercise is when it comes to the trigonometric functions. Okay, this also I'll just solve here only. It is very easy, right? Xy, just you can just try to solve. Okay, it is very easy only. Xy is nothing but it is in the product form. So, okay, maybe this question I'll solve it separately here. Okay, xy plus y square is equal to tan x plus y. Okay, so xy is nothing, you can't simply differentiate because it's the product rule. Product rule I told you in the previous video. I'll just tell you here, uv is equal to u dv plus v du. I mean the differentiation of this. Okay, okay, this is the formula. So now you will get x dy by dx, keeping x as a constant, differentiating y, plus y, keeping y as a constant, differentiating x with respect to x is 1 only. So y square, if you differentiate, 2y dy by dx. Understood? Tan x differentiation is secant square x. This is all you have to remember. Okay, no other go. Sin x is cos x is minus sin x, tan x is secant square x, secant x is secant x tan x. Like that you can see for cot x. Even I don't remember for cot and cosecant. You can see that. Okay, dy by dx. Now solve is very easy now. So you can just you can keep all the dy by dx's here. So y minus secant square x is equal to dy by dx. Take common 1 from here, it is 1, from here it is 2y, from here it is minus x. That's all. Just solve here, bring this here, that's all. Simple, right? So fourth also solved. Similarly, you can try fifth one, sixth one, seventh one, maybe eighth I'll put. Okay, eighth is nothing but simple only. Sine square x plus cos square y is equal to 1, right? Yeah, it's not the identity, okay, because there's different variable. Now sine square x differentiation, okay, sin x differentiation is cos x, right? So first sin square is nothing but sin x the whole square. So 2 sin x into sin x differentiation. So this is nothing but sin x the whole square, right? Both are same. Now sin x the whole square means this is also in a form of x square or y square, right? So that differentiation is 2x. So 2 sin x. Now chain rule, again differentiate sin cos x. Understood? Similarly, you will get 2 cos y into cos y's differentiation is minus sin y. Again, y's differentiation is dy by dx. Understood? Equal to 0. You're basically generating dy by dx inside the equation itself. That is why it's called implicit differentiation. Okay, so this is nothing but 2 gets cancelled. Now sin x cos x, this is minus, right? So when it goes there, it will be cos y sin y dy by dx. That's all. Bring this here. Problem solved. Understood? These are very easy only. The problem comes with trigonometric functions. I'll try to solve all according to time. Okay. So now this is nothing but y equal to sine inverse of 2x by 1 plus x square. Okay. I have written the formulas here. If you want, take a screenshot. So these are the formulas. Okay. I will try to copy this. So these are the formulas. Okay. Now just see the formulas and identify which is looking like this. 2x by 1 plus x square. This one, right? So you can bring this here. Okay. You can substitute x equal to tan theta. See what happens. Okay. You get y is equal to sine inverse of 2 tan theta by 1 plus tan square theta. Now what is 2 tan theta by 1 plus tan square theta? It is right in the right here. It is nothing but sine 2 theta, right? So this will give you sine inverse of sine x is x only. inside the domain, but they've given specifically the domain here, so no need to worry. Like in this question they've not given, but all this question x is the domain they've given, so no problem for that. Okay, so sine 2 theta, so this will be 2 theta only. So y equal to 2 theta. Now what is theta? X equal to tan theta, so theta equal to tan inverse of x, right? So y equal to 2 tan inverse of x. That's all. That's all, my friends. Like, solved, problem solved. Now, what is the differentiation of tan inverse x? You have to remember. Okay, tan inverse of x is 1 by 1 plus x square. I solved for sine right here. You can simply try it for cos and tan. Okay, now 1 by 1 plus x square. So this will be 2 into 1 by, so 2 by 1 plus x square. That's all. Simple. Only thing is trigonometry comes in picture here. Okay, so you have to remember the trigonometric identities. That is the only catch. We'll go to the next question, similar question. 10th one is y equal to tan inverse of 3x minus x cube divided by 1 minus 3x square. So again, you have to remember the formula, right? So what is the formula? Tan 3 theta formula. It's looking like tan 3 theta formula. Substitute again x equal to tan theta. If you substitute that, you'll get y equal to tan inverse of this whole thing. If you put, you'll get tan 3 theta only. Understood? Direct formula, right? So this will be 3 theta again. So this will be 3 tan inverse of x. What is differentiation of 3 tan inverse of x? Dy by dx. So this is nothing but dy by dx. Okay, don't forget this. Dy by dx is nothing but 3 by 1 plus x square. Understood? Okay. Now the next one is 11th question. Y equal to cos inverse of 1 minus x square by 1 plus x square. Just see the formula here. Okay. We're just looking like this. Can you see this? Again, put x equal to tan theta. Can you proceed this? Cos inverse of, little bit catch here. So when you put 1 minus tan square theta by 1 plus tan square theta, you get cos 2 theta. So this is direct. So you get cos 2 theta, nothing but 2 theta. So it will be 2 cos inverse of x. Okay. So what is cos 2 theta's formula? Minus 1 by root of 1 minus x square. So this will be minus 2 by root of 1 minus x square. Understood? Now, similarly, if you see the 12th question, it will look similar only, but see the catch here. 12th is nothing but y equal to sine inverse of, what is this? 1 minus x square by 1 plus x square. If you put the same x equal to tan theta in this question, right? Now you will get y equal to sine inverse of same thing, but it is cos 2 theta. Now you will wonder what to do. Sine inverse of cos. Sine inverse of sine is the theta itself directly, the angle. Now what you can do here? So how is sine and cos related? Sine of 90 minus theta is cos theta, right? You can use that formula here. There will be sine inverse of sine of pi by 2 minus 2 theta. Understood? That is why it becomes cos 2 theta, right? So this will be directly pi by 2 minus 2 theta, which is nothing but, because sine inverse of sine x, which is just x only. So pi by 2 minus theta is nothing but tan inverse of x. But if you see the catch here, this is nothing but, this is just like, you can tell this is like a confusion. Now when you do dy by dx, pi by 2 is a constant, so it will be 0 only. So it will be directly minus 2 by 1 plus x square, because tan inverse of x differentiation is 1 by 1 plus x square. Understood the catch here? This is what I wanted to tell. Okay. Next question. This is 13th one. 13th question is nothing but y equal to cos inverse of 2x by 1 plus x square. See the formula here. I think this is sine 2 theta, if I remember correctly. 2x by 1 plus x square. See, sine 2 theta. It is looking like sine 2 theta, right? Third formula. So you can directly put again x equal to tan theta. Now you'll get y equal to cos inverse of sine 2 theta. Same thing. If you do cos inverse of cos of pi by 2 minus 2 theta. Understood? This will be nothing but pi by 2 minus 2 theta. This will be nothing but pi by 2 minus 2 tan inverse of x. When you differentiate this again, it will be 0. It will be minus 2 by 1 plus x. Oh, is this the same answer we got for the previous question? Yes. This is the same answer. Okay. It happens, right, in math. So nothing to get surprised. Am I going fast? Like, you understood, right? Everything. Just do let me know in the comments. Okay. It's very easy only. Just trigonometric formulas you have to remember. Okay. Inverse trigonometric differentiation is not about differentiation at all. It's about trigonometry. How well you did your trigonometry in class 11th. Okay. 14th question. 15th question is a little bit tricky. Like, you try and let me know. Okay. Similar only. Like, very similar only. Just take, because it is in secant inverse, right? You have to convert. I'll just tell you now only. Like, you have to take cos 2 theta. Okay. Cos 2 theta. And you have to convert it in terms of secant 2 theta to do this. Very easy only. Otherwise, I'll tell you in the next video also. Okay. So, y equal to sine inverse of 2x root of 1 minus x square. So you have to look into the picture, like how it's looking. Like root of 1 minus x square. What can you relate? Like, if you put x equal to sine theta or cos theta, can you do something? I'm just trying it blindly with you, okay? When you put x equal to cos theta, um, yeah, like when you put x equal to cos theta, what will happen? Y equal to sine inverse of 2 cos theta root of 1 minus cos square theta, right? So y is nothing but sine inverse of 2 cos theta, 1 minus cos square theta is sine square theta. Root of sine square theta is sine theta. So sine theta. Do you know what is this? This is nothing but sine 2 theta. Okay? Sine 2 theta. Sine 2 theta is nothing but 2 theta cos sine. Sorry. Sine 2 theta is nothing but 2 cos theta sine theta. Now this is nothing but y equal to sine inverse of sine 2 theta. This is 2 theta only. So when you put, what is this? Theta equal to cos inverse of x. So 2 cos inverse of x. Nothing but minus 2 by root of 1 minus x square. Understood? Try the 15th question alone. Just pause the video and try. I'll tell you in this video only. Okay. To solve. Okay. Y equal to secant inverse of 1 by 2x square minus 1. Can you see what is happening here? It is asked, they're asking secant inverse, but inside they've given 1 by 2x square minus 1, right? Can you see what is the formula you can use here? Just come up and see the list of formulas we wrote. See, 2 cos square theta minus 1. Because cos and secant are inversely proportional, right? 1 cos theta equal to 1 by secant theta. So you can use this. I'll tell you how. Okay. So if you would have tried and got the correct answer, like, congratulations. So y, put x equal to cos theta. Okay. So your y will be secant inverse of 1 by 2 cos square theta minus 1. So this will be nothing but secant inverse of 1 by cos 2 theta. This is nothing but secant inverse of secant 2 theta. Okay. So this is again same. This will be 2 theta only. So your y will be 2 cos inverse of x. Nothing but minus 2 by root of 1 minus x square. Now all the problems when you see here, you somehow the question is simplified to either cos inverse of x, tan inverse of x, sin inverse of x. That's why I'm telling you to remember these problems, these formulas, very, very important. Okay. Of course, the other trigonometric formulas which we discussed are also important. Okay. Using these, you can easily solve. Okay. I think I've solved almost all questions, right? So I've solved 9th, 10th, 11th, 12th, 13th, 14th, 15th. 5, 6, 7 alone, you people try. You just ask me if anything is wrong, like any doubts or anything in the video also. Also tell me if I'm going fast in the video. I'll try to reduce my pace, okay? Now, next up is logarithmic and exponential functions and their differentiation. I think I'll teach you logarithms and exponential from basics only. Don't worry. After that, we can solve logarithmic differentiation and exponential differentiation, everything. Okay, these are very easy only. Nothing to worry. Looking like very complex, right? I'll make it simple. Okay, no problem. Yeah. Okay, guys. I think that's all for this video. Hope you guys liked it. Thank you for watching. Bye, guys.